Bismillahirrahmanirrahim. Assalamu alaikum dear students. In this semester, we are going to study the course Electromagnetic Theory. This is lecture number 1 for MSc Part 2. I am your instructor, Alam Khan. Today the topic we are going to study is about electric current. Before going into the detail of electric current, you must know about the electrostatics and electrodynamics. As you know, electrostatics consists of the two words. First part is electro means charge. Second is statics, means at rest. So electrostatics is a branch of physics that deals with the charges at rest. Second is electrodynamics. Electro means again the charge, and dynamics means motion. So electrodynamics is a branch of physics that deals with the charges in motion. Types of materials. We can classify the materials on the basis of their conduction mechanism. First one is conductor, second is semiconductor, and third is insulator. Conductors are those materials which can carry the current easily. On the other hand, insulators are those materials which do not carry current. In between them, some materials are semiconductors. They are insulated at low temperature, whereas they behave as a conductor at high temperature. We focus ourselves towards the conductor. Conductors are those materials in which charge carriers are equal. For example, metals, alloys, semiconductors, electrolytes, ionized gases, imperfect dielectrics, vacuum in vicinity of fermionic emission diode. Metals. In metals, charge carriers are free electrons. As you know, electron carries the negative charge, whereas in electrolytes, charge carriers are both positive and negative. Now, come towards the main topic, which is about current. Moving charges constitute current, and the process in which charge is transported from one place to another place, that process or mechanism is known as conduction. So, the current can be defined as the rate at which the charge is transported through a given point in a conducting system is known as current. Mathematically, we can write current as I is equal to dq divided by dt. Means the rate of flow of charge is known as current. Here, Q can be defined as Q is equal to Q of t. Means net charge transported in time t. The unit of current is ampere. Ampere can be defined as if 1 coulomb charge moves through a conductor in 1 second, it means 1 ampere current is established in that conductor. Now, we are going to study the nature of current in different materials. First one is metal. When we study about the structure of metals, we see that heavily positive ion fixed at their position. As we can see in this diagram, where the large circles containing positive charge fixed at their position. Whereas the free electrons, or known as the valence electrons, in metals are free to move. Whereas those electrons which are close to the nucleus always remain stuck to the nucleus. When we apply some field across the metallic plate, the charge imbalance creates. Means electron move towards the right hand side, whereas the absence of electron will move towards the left hand side. But as a whole, metal is electrically neutral. Here, when we study about the metals, we ignore the electrostatic forces present among the different charges. Second type is electrolyte. The nature of current in electrolyte depends upon both the positive and negative. It means current constituted in electrolyte is due to both positive as well as negative ions. But some ions move faster, whereas other ions move slower. We can say that one type of ion usually predominates in conduction. Movement of positive and negative ions are in opposite direction, as you can see in this figure. Here the negative ion move towards the left hand side, whereas the positive ion move towards the right hand side. Net charge transport in the electrolyte depends on the two types. First one is the sign of the charge carriers. Second is the direction of the charge carrier in which they are moving. But conventionally, we took the current direction in which direction positive ions are moving. That direction is known as conventional current direction, whereas electronic current is in its opposite direction. In electrolyte, electric current is set up in response to an applied electric field. When we apply the electric field across the electrolyte, positive ions move toward the negative side of the battery, whereas the negative ions move toward the positive side of the battery. Third category is gas discharge. In gases, current constitutes due to electrons and positive ions. But as we know, electrons are lighter particles and much mobile as compared to the positive ions. So, in gases, current is constituted due to the flow of electrons. Thermionic emission is a process in which, by hitting a metallic surface, ions are ejected from the metal surface, that is known as thermionic emission. In this process, free ions strike with the neutral atom present inside the gas. That collision will produce more ion electrons in the gaseous state. This process is known as ionization. When we are discussing about Motion of the charged particle can be classified into two categories. First one is the drift motion, and second one is the thermal motion. In drift motion, charged particle in the presence of some field, that motion is known as the drift motion. The drift motion is highly organized, whereas thermal motion, charged particles move due to the heat or temperature changes. This thermal motion is large, occurring at low and high temperature, but not organized. Means charged particles move in random manner. Conduction in thermal gradients is known as thermoelectric. Current can be classified into two categories. One is known as conduction current, the other one is known as convective. In conduction current, drift motion of the charge carries through the medium. But here in conduction, medium itself is at rest, only these charge carriers are moving through that medium. Second category is about convection current. This occurs in liquid and gases. In liquid and gases, current is constituted by the hydrodynamic. In liquid and gases, the medium has some charge density. It means if the medium has some charge density, hydrodynamic motion will occur, and hydrodynamic motion will constitute the current in that materials like liquid and gases. Or we can say that conduction current is due to the mass transfer. The example of conduction current is atmospheric electricity and the motion of the charged particles. But here, in conduction current, they are not electrostatically clear. Thank you.